This is Module 2, Lesson 13, Pythagorean Theorem word problems, where we're going to apply Pythagorean Theorem to determine unknown side lengths in triangles, okay? We're going to do these in word problems. Now, these are indeed in your packets. I think this is page 30 something. I can't remember exactly. Look for it. It says Pythagorean Theorem word problems, okay? And we're going to work these together. Now notice when you do a word problem, it's probably not going to have all these things here. This is scaffolding to help you figure out what to do. It tells you when you're reading it, you should draw a picture, you should solve it, and remember to find the solution, okay? So let's work on this right here. Let's work on this. And remember, every time, guys, on this, we're going to need to draw what we're talking about so we'll understand it. And if it's Pythagorean theorem, we know we got to have right angles, right? Right triangles. A flat screen TV in the shape of a rectangle, see, I'm underlining things I know, has a width of 36 inches and a height of 20. What is the length of the diagonal? They want the diagonal. So let's draw this figure, okay? I'm going to try to draw it, okay? Okay, there's our TV, and there is our diagonal, and we're trying to figure it out from there, right? Okay, we know that if you've got a rectangle, that you've got right angles, don't you? All four of those were right angles, aren't they? They want the length of this diagonal. I'm going to put D here. It says the width is 36 and the height is 20, so 20 here. Height is 36. We're looking for this D. Okay. But this isn't a triangle. This is a rectangle. But what if we get rid of that side and we get rid of that side? Okay. We erase this here. We erase this here. We erase this here. I am looking at a right triangle, aren't I? I'm just taking half of it, and I can look at a right triangle. Okay, and they will do that to you a lot when they're talking about rectangles. And we're trying to find this side, which is across from the right angle. We know Pythagorean theorem says a squared plus b squared is equal to c squared, and it's used to find side lengths and right angles. This d is across from the right angle. I'm going to call that d squared. Doesn't matter which is a and b here. I will substitute 20 in for A. I'm going to substitute 36 in for B. Okay, using our calculator, 20 squared. Okay. 20 squared gives me 400. I'm going to substitute 400 in the place of 20 squared. 36 squared gives me 1296, 1,296. I'm going to substitute that in the place of 36 squared. And that's equal to d squared. Okay, now let's look, see if I'm adding or subtracting. And in this place, I need to collect like terms before I cross that equal sign, Donna. So I am going to say 1,296 plus 400, and that's equal to 1,696. And that's equal to d squared. Okay? Now, here's the thing. We're going to take, we don't want d squared, we want d. So let's take the square root of d squared. Okay. And d is equal to the square root of 1,696. Second function square root 1,696. And that's going to equal to 41.2. Okay. So the solution is that it's 41.2 inches. Simple enough. We're looking at inches, 41.2 inches. Okay. Now, does that make sense? That would be the long side, 41.2. I got 20 and 36. That would make sense. Okay. Let's look at number 2. A 20-foot piece of wire is attached from the bottom of a flagpole. So I'm going to draw a flagpole. I'm going to draw the ground here. And I'm going to draw me a flagpole. Okay. Here's a flag. All right. You know, flagpole's at a 90-degree angle to the ground, right? A 20-foot piece of wire is attached from the top of the flagpole to a stake in the ground. So we're going to put a stake here in the ground. I'm going to put this 20-foot piece of wire on it, okay? That wire is 20 foot long. This stake is 8 feet from the flagpole. Find the height of the flagpole. Here's your height, okay? This is going to take Pythagorean theorem because we have a right triangle right here. Let's look to see where our right triangle is. See, there's your right triangle, guys. I know I can't draw it very well, but there's your right triangle. There's your H that you're looking for, okay? So let's use what we've got and let's solve our problem, okay? If you're looking at that, we know it's a right triangle, so we're using Pythagorean theorem. A squared plus B squared is equal to C squared because we're looking for a side length in a right triangle. A squared plus B squared is equal to C squared. Okay, your C is across from the right angle, it's 20. Your A and your B, doesn't matter which is which. 8 squared is 64. Plus H squared is equal to 400. Okay, now we're trying to get H squared by itself. Okay, subtract 64 from each side. H squared then is equal to 400 minus 64. 336. Take your square root on H squared, and H is equal to the square root of 336, 18.3. Okay, that is, it says the height is 18.3. Does that make sense? Your long side is 20, your two legs are 8 and 18.3. That makes sense. Number 3. A 14-foot ladder is leaned against a wall. Okay, so we're going to have a wall. We need a building. There's a building. Here's the ground. A 14-foot ladder is leaned against a wall. Okay, so here's our ladder. I'll draw little rungs on it so you can kind of see it. Says it's 14 feet long. If the base of the ladder, and here's your right angle, if the base of the ladder is 6 feet from the wall, how high up the wall will the ladder reach? Okay. Now, if you look closely, guys, what we're talking about is a right triangle here. Let's look at our right triangle. Here's our right triangle. It's right there. Okay. Now, we know where our right angle is. We know where our H is. Our C is always across from the right angle. A squared plus B squared is equal to C squared. C is across from the right angle. It is 14. A and B. Doesn't matter which is which. A could be 6 squared. B could be H squared. 6 squared is 36. H squared is H. Okay, and then 14 squared. 14 squared. 1,196. Okay. Let's subtract 36 from each side. H squared is equal to 196 minus 36. It's 160. Okay. Let's take the square roots. Because we don't want H squared, we want H. The square root of 160. It's 12.6. H is equal to 12.6. Okay? That's 12.6 feet. Okay? Now let's see if this makes sense. Hypotenuse is 14. It's crossing the right angle. This side 6, that's 12.6. Okay? Makes sense because this is the long side. Let's look at number 4. Josh and Ben spot a bear in the woods while riding their bikes. Okay, so we're going to be drawing as always. Josh rode 3 miles north. So here's our bear. Okay, I'm going to put us a bear here in the woods. Scary bear, all right? They see the bear. Josh goes 3 miles north. There's Josh, okay? Ben rides 2 miles east. East is perpendicular to north. So Ben went 2 miles east. What they're looking for here is how far apart the two boys are. This is the distance. We'll call it D. How about that? Instead of H, we'll call it D. We're looking for the length of a line on a right triangle of a side. A squared plus B squared is equal to C squared. Okay. D is across from the right angle. That's the distance between the two boys. One side of this is 3, the other side is 2. 3 squared is 9, 2 squared is 4, is equal to D squared. Now look, we need to collect these like terms before we cross the equal sign, right? 9 plus 4 is 13. We're solving for D, not D squared, so we take the square root of both sides. D would give you the square root of 13 in your calculator. Go second function, square root of 13. And you get 3.6. D is equal to 3.6 miles, right? Would that make sense? Let's look and see. This side is 3, this side is 2. Across from the right angle is 3.6. Okay? How far from the base of a house should you place an 18-foot ladder if it's to reach a window that's 15 feet high? 18-foot ladder, 15 feet high window. They want to know how far from the base of the house you want to be. So let's draw our house, okay? I just usually draw something that looks like a building, and I put my windows there so I know it's my building. You don't have to go that far. I draw the ground because this is where my right angle is. And here's my ladder, okay? Put little rungs on my ladder so you can see my little ladder. The ladder is 18 feet long. So here's my ladder, it's 18 feet long. The window is 15 feet high. They want to know how far the base of the ladder is from the base of the house. Okay. There we go. There's our right triangle. Okay, Pythagorean theorem. Because I'm looking for a side of a right triangle. A squared plus B squared is equal to C squared. And the C is always across from the right angle. It doesn't matter about the A and the B. Okay, so for C, that's 18 squared. A is equal to 15, and they'll square it. And that's B squared, or X, whatever you want to call that. 15 squared in your calculator is 225. Plus X squared is equal to, and let's do 18 squared. 18 squared is equal to 324. Okay, now let's see what I need to do. Well, I'm adding this to X, but I'm looking for X, so I need to subtract 225 from X, right? If I subtract 225 from X, I get X squared is equal to 324 minus 225. And that gives me 99. I'm not looking for X squared, I'm looking for X. So take the square root of both sides. And X is equal to, second function, square root 99 equals 9.9. Okay, solution, 9.9 feet. Okay. Let's skip number 6. Let's go to number 7. A football field is 120 yards long by 53 yards wide. So if we've got a football field, it's a rectangle, isn't it? 120 yards long by 53 yards wide. If a player runs diagonally from one corner to the opposite corner, okay, there he is. How far will he travel? This is the distance he will travel. We did one just like this on the last page. Remember, guys, when we did the flat screen TV? Okay. To get to it just being a triangle, let's erase this triangle, this part of the rectangle, okay? And we are looking at a triangle here, right angle there, because you'd have a right angle if you were looking at the football field in the corner. Now, let's use Pythagorean theorem. A squared plus b squared is equal to c squared. Okay, the c squared is across from the right angle. It's d. A is 120. B is 53. 120 squared. Okay. If you square 120, you get 14,400. So we're going to substitute that in its place. 53 squared. 2,809. Okay, equals d squared. Okay, now if you look at this, guys, to get to the d, I'm going to need to clean this up. I'm going to need to add these two, right? Okay, I've got 17,209 is equal to d squared. The opposite of squaring d is to take the square root of it. D is equal to 131.2, and what would that be? Yards. Now let's see if that makes sense. This side's 120, this is 53, this has got to be the longest side across from the right angle, so that does make sense. Number 8. On a map, Norristown is 18 miles south of Lincoln. Okay, so let's put Lincoln here. Norristown is 18 miles south, okay? Here's Norristown, and it's 18. Lincoln is 29 miles west of Allenport, okay? 29, and there's your Allenport. What's the difference between Norristown and Allenport? Well, look, guys, right angle if they were talking about south and west, right? We did one just like that over here. When we were doing this earlier, we were talking about the bear. We did one that was north and east. Now we're doing one that is south and west, okay? So same situation. How do I find the distance between Norristown and Allentown? We're using Pythagorean theorem. A squared plus b squared is equal to c squared. X is across from that. That is your c. Okay? A and b. 18 squared plus 29 squared is x squared. Okay? 18 squared. 324. 29 squared. 841 equals x squared. Let's add these two together. 1,165 equals x squared, okay? Now, let's take the square root, and x is equal to the square root, second function square root of 1,165, and you've got 34.1, okay? Would that make sense? The long side is always across from the right angle, the hypotenuse. That's 1829 for the two legs, 34.1, that would make sense. 34.1 miles, okay? Number 9, a set of stairs is 10 feet tall. So we're talking about a set of stairs, okay? And it's 10 feet tall. Here's our stairs. And it covers a horizontal distance of 12 feet. If the handrail is to be installed, okay, that extends the entire length of the stairs, what length must it be? We need to know the length of this. That is across from the right angle. And this is a right triangle. A squared plus b squared is equal to c squared. Okay, L is your c, your length is your c. Doesn't matter which one's a and b. 10 squared plus 12 squared is equal to L squared. 10 squared is 100. 12 squared is 144. That would give me L squared. Notice, before I cross the equal sign, I need to collect all the like terms. I have 244 is equal to L squared. I need to take the square root on each side. L is equal to the square root of 244. Second function, square root 244. And I've got 15.6. Okay? So this is 15.6 feet. All right? That would make sense because the hypotenuse is going to be the longest side that's across from the right angle. Okay. Kara's flying a kite at the park. So here's Kara, okay? She's flying a kite. Here's a kite, okay? She's got a string that's 42 meters long. Okay, 42 meters. Let's see. So the string on this kite is 42. Okay, she noticed that the kite is directly above her friend Leah. Okay, there's Leah. Leah, Kara, right? If they're standing 36 meters apart, that would be 36. How high is the kite? So how far is this kite above the ground? Look, there's your right angle. Okay, we're looking for how high the kite is. I've just drawn a right triangle, haven't I? Using a right triangle, we can use Pythagorean theorem to find any missing side. We know our hypotenuse across from the right angle. Let's see. Your A, doesn't matter which is A and B. $36 squared, 1,296 plus H squared is equal to 42 squared, 1,764. Now I'm trying to get to H squared, all right? Notice the 1,296 is added to the H squared, so I need to subtract it from both sides, don't I? Subtract 1,296 from both sides, and H squared is equal to, let's see, 1,764 minus 1,296. That would give me 468. I'm not looking for H squared, I'm looking for H. So I take the square root of this H squared and I take the square root of that. And H is equal to the square root of 468. Second function, square root 468. Would give me 21.6. Okay, that is in what, meters? But let's look and see if that makes sense. The longest side is the hypotenuse. The two legs are shorter than the hypotenuse. That makes sense. Okay, notice, guys, there's so many word problems that we can solve that involve Pythagorean theorem. If you can draw a right angle, if you can draw a right triangle to represent your problem, then you can probably use Pythagorean theorem to solve it if it involves a side length. Now, we have done that a lot of times on testing. They love to use ladder problems. We did a couple of ladder problems. You've seen the Northwest problems. They like to use problems that involve rectangles where you leave out one side of the rectangle, one half of the rectangle. You've seen lots of different things. If you can take your word problem and draw it as a right triangle, and you're missing a side length, then you can use Pythagorean theorem to solve it.